All right, so writing chemical formulas. So a chemical formula, right, is a short way of writing out the name of a chemical. So sodium chloride, that's salt, okay, that we put on our french fries every day, or whenever you french fries, every day. And instead of writing sodium chloride, we use the symbol for sodium and the symbol for chlorine, and we put them together. Okay, it's much easier to write like that. It's also much easier when you start doing balanced equations. Okay, so the first step in writing chemical formulas. Okay, the first step in writing chemical formulas is to write the ions side by side. Write the ions side by side. We write the ions side by side. Remember, ions are charged atoms. Okay, they're non-neutral atoms. So one of them will typically, for ionic compounds, one of them will be a positively charged ion, and one will be a negatively charged ion. We always write the positive on the left side and the negative on the right side. Okay? We always write the positive on the left side and the negative on the right side. So our example that we're going to use, we're going to have these two ions. One of them is iron 3. Okay, so it has its symbol and then its oxidation number, which is 3+. And the other is sulfide.
You put these on the other page, or did you?
Yeah, I want these all like this. So we're writing our ions side by side. The positive goes first, then the negative. Okay. So if we were given the chemical iron sulfide, this is how you would write it. You would look on that list that you just put into your notebook, and you would find the word iron and see what its ion is, and you would find the word sulfide and see what its ion is, and write them right next to each other like that. So step two is to draw arrows from the charges that cross each other. Okay, so we're drawing arrows from the charges that cross each other. So we have our iron 3 and our sulfide. And I'm going to draw arrows from the charges. So the first arrow I'm going to draw starts up here by the charge that's 2 negative. I'm going to draw it to like the bottom corner of iron. And I'm going to draw an arrow from the 3 positive to the bottom corner of the sulfide ion. So our step 1 was to write our ions side by side, and step 2 we're going to draw the arrows from the charges and let them cross each other. For step 3, we're going to put the number only from the charge at the end of each arrow. This is called the crisscross method. going to transfer the number from the top to the bottom, and we're not going to use the chart, just the number. Step 4. For step 4, we're going to write the positive ion without its charge. This is the actual writing of the formula part. There are 7. But these ones are here easy. They're easy. For step 5, we're going to write the number by the right arrow as a subscript. So this will be S, E, and what is the number by the arrow that started from the right? 2. Two. So we're on step 6. Step 6, we're going to write a negative ion without the charge. And it's important here that you do not leave a space. Okay, so no spaces. No spaces. So this should now look like this. Fe2, and the negative ion, which is the sulfide, goes there. And then what do you think we'll do for our step 7? We'll put a 3 on the S. Very good. So step 7 is we'll write the number by the left arrow as a subscript. And then, sorry, I think I lied to you. I think I said there were 7, it's actually 8, but this 8 one you don't do every time. Okay, so the last step is to reduce if needed. So if instead of Fe2S3, this was like Fe2S4, okay, we could reduce. Right there. Okay. So there's couple key things that we need to know. The first key thing is we don't use the number 1 as a subscript. Okay, we don't use the number 1 as a subscript. So if this was FE1S2, we would just write it as FES2. Okay, we wouldn't write the number 1. Okay? What these subscripts tell us is how many of each of the elements there are in this compound. So for this one, there are 2 irons and there are 3 sulfurs. Okay, so when there's just an Fe with no subscript, we just assume there's only one of them. Okay, so like in the compound sodium chloride, okay, there are no subscripts there. So this is a 1-to-1 ratio of sodium to chlorine. There's 1 sodium and 1 chlorine in that compound. Okay? For this one, there are 2 irons and 3 sulfurs. So let's put this to work. Let's do some practice here. Okay? Let's say we have calcium oxide. Okay, so what does your very first step tell you to do? Write the ions side by side. So on that list that you put into your notebook, what is the ion for calcium? It will be its symbol and its oxidation number. Or you could also get it from the periodic table. Ca2 plus. Excellent. Ca2 plus. And remember, the one that has the positive, the one that's the positive ion, which is also called a cation, that always goes first. Okay? The one that's going to be the negative ion, which is also typically the non-metal, goes second. So what is the ion for oxide? What is it? O2 what? O2 negative. Very good. All right, so we got them next to each other. Now what's our next step? We're going to do the crisscross method. We're going to draw the arrows to the corners of the opposite elements. Okay? Then what do we do? Alright, so we're going to put the number only, not the charge, at the end of each arrow. So there's a 2 there and a 2 there. Now what? Okay, write the positive ion without the charge. So we have calcium. Now what? Add the 2. Okay? Write the O. And then the 2. And step 8 says to reduce. Should we reduce this one?
How do you reduce?
If these are the same number, like we could divide both of those by 2 and we could get 1. Okay? So this would become Ca1O1, but what do we know about 1s? We don't use them. Okay, so when we reduce, yeah, the answer is CaO. That is the formula for calcium oxide.
What if that was a 2?
Let's do one where we wouldn't reduce it. Let's see here. Let's do. Let's do aluminum oxide. Let's do aluminum oxide. Aluminum oxide. Okay, what's our very first step? Write the ions side by side. So what's our ion for aluminum? Al, and its oxidation number is 3+. Okay? And you guys don't design on this to find this, because you already know how to do this, okay? The symbol is going to be, the ion is going to be the symbol for the name, aluminum. Okay, that's pretty easy one, Al. And this charge number is the oxidation number, and that comes from the periodic table. So we learned that our representative elements, group 1 is a 1 plus, group 2 is a 2 plus, 3 is a 3 plus. We skip group 4, we actually do group 14. Then we start back again on group 15 with nitrogen. It goes 3 minus, 2 minus, 1 minus, and 0. Okay, so since aluminum happens to be in group 13, it's a 3 plus ion. Okay. So what's the symbol and oxidation number for oxide? O2 negative. Alright, so now what are we going to do, Daniel?
We're going to cross.
Cross. Good. So we draw an arrow over here, and we'll draw an arrow over here. That's the crisscross method.
The Al2O3.
Okay, good. So Daniel kind of skipped this step. I'm going to just draw those in. Okay? But he said now this is going to be Al2O3. And he's absolutely right. Now can we reduce 2 and 3 and make them whole numbers? No, they're good just the way that they are. So that is the formula for aluminum oxide. Let's do another one. Let's do iron 3 oxide. Alright, let's do iron 3 oxide. And this one kind of throws a kink in there. Okay. Iron is one of the transition elements, which means that it doesn't follow the trends. So sometimes it can have different numbers of valence electrons, or different numbers of oxidation numbers. So when you see something, an element that has a Roman numeral next to it, okay, you should know that that's a transition element, and that Roman numeral tells us something, okay? So the first thing the Roman numeral tells us is that this element is a metal, okay? And the number is its number for its oxidation charge, okay? So this is iron, that's iron symbol, and we know that it's going to have a 3 there because that's what that Roman numeral tells us. And the other thing that you should know about these Roman numerals is that they're always positive. Okay? Always positive. Okay? Always positive, and they have a given value. Okay? So you need to know the Roman numerals. Is there anybody who doesn't really know the Roman numerals? I'll write it down real quick if you don't. Okay? This is 1, 2, oops, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Those are the Roman numerals 1 through 10. The V means 5, and I before the V means the number before 5, which is 4. An I after 5 is a 1 plus 5, so this is 6, 7, 8. The X means 10, so the I before the 10 means the number before, which is 9. Okay, so here is our positive ion. Okay, what is the symbol for the negative ion? O2 minus. Alright, now what? We're going to crisscross them. And what do you get? Fe2O3. That is our formula for iron 3 oxide. Iron 3 oxide. Okay, pretty easy?
Yes.
good. Okay, there's one other thing. Let's look at potassium hydroxide. Potassium hydroxide. So potassium is something that you've heard of before, but hydroxide might be new. Okay? Hydroxide is what we call a polyatomic ion. What does the word poly mean? More than one. Okay? So monatomic ions, mono means one. Potassium is a monatomic ion. It only has one atom. Okay, with it. But polyatomic ions have more than one atom. So it just so happens if you look on your paper on the ion list, hydroxide is OH and has a 1- charge. Okay? And this thing behaves like a monatomic ion. Okay? Even though it has more than one element, it still behaves like it's just one thing. Okay? It's like oxygen and hydrogen are joined, they're best buddies. They're not going anywhere without the other. Okay? They never get separated. Okay? So we're just pretty much attaching this to our potassium. Okay? Our potassium cation. So this works the same way. Okay? We put our ions next to each other. We do the crisscross method like this. Okay? And so these are both going to be one. What do we know about ones? We don't need to use them. So what is this going to end up looking like? KOH. Capital K, capital O, capital H. Okay? That is the formula for potassium hydroxide. Okay? Pretty easy. All right, let's do one more of these. Let's do aluminum hydroxide. Do aluminum hydroxide. All right, what is our formula for aluminum? Our ion formula. Al3+. And what is our formula for our hydroxide? OH. 1-. Okay. So we're going to crisscross and crisscross. So we get Al with a 1 and the OH with a 3. So we could write this AlOH3, but this is wrong. Okay, this is wrong. The reason why it's wrong is that this 3 has distributive properties. Okay? That means that we're not just saying there's 3 H's, we're saying that there are 3 OH's.
And would it be a base 3?
Well, sometimes it's like that, but not when it's a formula. What we have to do in this case is we have to show that the OH is protected, that it sticks together. So the way that we do that, we just put parentheses around it. So anytime that you're going to give a polyatomic ion a subscript like this, you're going to have to put parentheses around it in the compound.
Yeah, that's what I was saying.
Have to put parentheses. So this looks like this. Al, parentheses, OH, and parentheses. The subscript goes on the outside. Okay. Some of your polyatomic ions have subscripts with them. Like, for example, carbonate is CO3. Okay, if we were doing carbonate here, we would have to put the parentheses around the O with the 3 and then put our subscript on the outside of that whole thing. Okay, just remember, you want to protect that polyatomic ion so that nothing can get to it and nothing can change it. Okay, this isn't changing anything. It's just telling us how many of this we have. Doesn't change the actual formula. Okay. All right.